Hello students, hope you are doing good. I'm going to record this video on the topic of functions and relations. So if you can look it up on my screen, I have this topic, the definitions, and then some examples of functions and relations. So let's talk about what is a relation first. A relation, as you can see on my screen, it is an association or a correspondence between two given sets. For example, in this particular example, I have four students or four people, John, Maria, Lauren, and Samuel. And I'm asking them, the question is, what is their favorite football team? Now, John is saying that he likes Patriots, Maria likes Giants, Lauren like Patriots, and Samuel like Eagles. So you can see there is a correspondence. So if you can see the correspondence here, there is a correspondence between John and Patriots because that's his favorite football team. Maria likes Giants. Then Lauren also likes Patriots, and Samuel like Eagles. So there is this one set of people, and then the other set of their favorite football teams. Now, the first set is usually called the domain of that particular relation, and the second set where we are mapping to or where the outputs are. For example, in this case, the question was choose your favorite football team. So wherever your outputs are, that's called the range. So set 1 is called the domain and set 2 is called the range of the given relation. So if I have to write the domain and range, I will write domain equals John in the set notation. Set means curly braces, John, Maria, Lauren, and Samuel. In the curly braces for the range, I'll have Patriots, Giants, and Eagles. Okay, so let's look at the next example. So for the next example, I asked four students, let me zoom out a little bit. I asked four students that what classes are you taking at Lone Star College in spring of 20? So if I the first student said I'm taking 1314, which is your college algebra, and EDUC 1301. The second student said he's only taking math 1314. My third student said math 1314. No, the third student said EDUC 1301 and ESL course, and the fourth student is taking 1314 and political science. So there is a question, there is a correspondence between the two sets. The set 1, which is your domain, has four students. Set 2, which is your range, has four courses. um, Although the student 1 is mapped, so if you can see the student 1, it is mapped to your 1314 and O3, EDUC 1301. Similarly, student 1 is only mapped to 1314. Student 3 is again has two outputs corresponding to one input. So there are two answers corresponding to your, let's see where this is going, EDUC and ESL. And student 4 has 1314 and political science. So some of the students have one, some of the students have two outputs. This is a nice relation of the students with the courses they are taking at Lone Star in the spring of 20. So now what is the difference between the first and the second relation? In the first relation, if you see, since I asked one, pick one favorite football team, the students, or for every input, I only have one output, right? So for every question asked, there is only one answer. It may not be unique, it could be unique, but one question, there is one answer, or one person, there is one team. Although in this case, I cannot do one, right? This is the case in which one student can take multiple classes. You can take two classes, three classes, or four classes. So the first set of relations have a special name, and those are called functions. So if you look here, a function right here is a relation if for each entry in the domain in the first set there is only one entry in that range. Now note that the entry in the range may or may not be unique. So note that the entry in the range may or may not be unique. Okay. So for example, the uh, the um, The first one, I think Patriots was the Patriots team was favorite for two people, Lauren as well as John. Now the first case is a function. If we have one for one input, there is only one output. Now that output may not be unique. For one input, if we have one output, that is your function. If we have multiple outputs, for example, in this case, I mean, it is a good relation. I'm not saying that functions are better or not. Just simple thing is whenever for one input you have one output, that's a function. That output could or could not be unique. If you have multiple outputs given to some inputs, then it's not a function. Now let's get to some math. The first one is my line y equals x. That's a line which passes through the origin. Um, And if you look at for each input, y equals x means x's are usually my inputs. So x is usually your input and y is always your output. Okay, so x is your domain and y is the range. So I can input any real number. X could be anything, and similarly, y could be, if x is anything and y equals x, then y is also any real number. So if you look at the diagram that I had drawn before, -2 is mapped to -2, -1 is mapped to -1. So the input values, which are x, and the output values are your y, right? And the map goes like this, the arrow goes like this. So as you can see, for one input, there is one output. There is this equation represents a function. The domain x can take all reals, and similarly, range is also all reals. Let's look at the second example, which is y equals x square. Now y equals x square, x can take any real number right here. You can input 1, you can input -1, you can input fractions, you can input rationals, you can input irrationals, any real number. But once you square any number, any negative, positive fraction, it gets positive, right? For example, if I square a -2, I get a 4. And if I square a 2, I also get a 4, right? You always get a positive number once you square a negative number. So the inputs could be any real number, which is right here, but the outputs is only positive or 0 square, which is 0. So the outputs are, if you look here, it's the square bracket 0 to the infinity, right? That's your outputs. The graph of this is a parabola, which is a U-shaped graph as shown in the picture right here. And you have this kind of picture is going on, my bad. So if you look here, if I want to draw the ovals, these are my inputs right here. So the inputs are two, negative two, those positive negatives, anything. But once you have your outputs, you will have this kind of scenario. Some of the inputs will have same outputs, but each input has one output. So this is a function. Remember, if one input has one output, it is a function. Output can be unique or cannot be unique, right? So you have multiples here. So I'm going to draw some dots, right? So this is your x value and that's your y value. Okay, so that's a function. Now I would want you to try y equals x cube in the discussions. I will upload this in the discussions. So try y equals x cube and let me know the domain range and whether it is a function or not. The next example is y equals square root of x. Now for this example, um, the input or domain has to be a positive real number. Whatever goes inside this radical has to be a positive real number or 0, right? I should have written 0. I should have written non-negative rather. So positive or 0 number has to go inside the radical. So domain is 0 to infinity, the right side of your x-axis, including the point 0. Now radical of a positive or 0 is always positive and 0. So it means that for example, radical of 9 is 3, right? Radical of 0 is 0. So it means the range is also positive. You input a positive and you're getting the output positive as well. On the right side, you see the graph of this square root of x or radical of x. And it is a function because for every input, you have a unique output in this case. Not only an output, but it is unique output. The next one is y equals absolute value of x. This behaves like the parabola. Uh, the domain, you can input anything, but your outputs are again positive because you are taking the absolute values of those numbers. So the domain is negative infinity to infinity, range is 0 to infinity. If you want to draw the some of the values, for example, let's take negative 1, 1, negative 1/5, 1/5. If you look at the outputs for these, negative 1 is mapped to 1, 1 is also mapped to 1 because the absolute value for both is 1. Negative 1/5 is mapped to 1/5, and 1/5 is also mapped to 1/5, right? So the range only has positives or 0. I can have a 0 which is mapping to 0, but the domain has everything. Negative infinity to infinity, as you can see right here. And also the graph extends indefinitely on left and right, but only stays in the positive side of y-axis, which is 0 to infinity. Okay. The next one is example 6. Now this is a different kind of graph. This is y square equals x. Now for this kind of function right here, this one, um, if you look here, um, since x is a square of a number, x is always positive, right? Because x is a square of a number right here. So x is always positive. It means domain is 0 to infinity, positive or 0. But once you enter any positive value here, since your y squared, let's look at this particular line right here. If x is 1, which is positive, you're solving for y square equals 1. Which two values square equals 1? Y equals plus 1 and minus 1. So what is happening here? Suppose this is my plus 1, this is my x value. It's mapping to two values in the y side, plus 1 and minus 1. So for every input, you have actually two outputs, multiple outputs, right? So similarly, if I input 4, I have 2 and negative 2. You're taking the radical, or you're giving me two numbers whose square is 4. So this case is not a function. This is a relation. Is this a relation, a function? No, it's not a function. And this is how the picture looks. This is my x side and the right side is my y side. One input, multiple outputs. So this is not a function. Actually, whenever you see y square in any equation, that's never a function. Think of another example where you see y square. That's circles, right? We just did circles before this one. So circles, all the circles, they are not functions. Okay, those are relations. So the next one is, excuse me. Now, if you look at the graphs below, I have two graphs right here. The first one is the parabola, which is y equals x square. The second one, the equation is written x equals y square. The difference is one is the parabola which opens up. The other one is the parabola that opens to the right. Now, there is a test. If you know the graph, there is a test to check whether that graph represents a function or not. So if you look at the first one, which is the parabola opens up, if you start drawing vertical lines, they intersect the graph at most one point, right? Similarly, if you look at the second one, x equals y square, if you start drawing vertical lines, they intersect the graph. Some of them don't intersect. Some of them on the right side intersect the graph at 2 points. So it means if you look at the second one, for this x value right here, this one where I'm drawing the circle, you have two outputs. One is here and one is here. Similarly, if I draw one more vertical line, I'll have two outputs. So the vertical line test, which is written right here, I would just read the bold part. If all vertical lines intersect a curve at most once, then the curve represents a function. Okay, if all vertical lines intersect a curve at most once. So think about this one. This is y equals square root of x. If I start drawing vertical lines, they intersect the graph once or at 0 point, or they don't intersect at all if I draw vertical lines here, right? So if it is at most once, this is the 0, some part does not intersect, some part intersect only once, that's a function. If it intersects more than one, that's not a function. Now, circles, if you think of circles, you draw vertical lines right here. They intersect more than one point. For every input, you have this output, you have this output. So they are not functions. Couple of other notes. Another way to write a function is using the f notation. F of x equals x squared. For example, y equals f of x. So this is your input right here, and your output or the rule is x square. Whatever you input, your output will be x square. For example, if your problem is f of x equals x minus 1 whole squared, let's zoom in a little bit. Then evaluate f of negative 1. These kind of questions are very popular in the higher math as well. I mean, you should know what the input does to the function. So for example, if this is my function, what is f of negative 1 and what is f of 3? F of negative 1 means input is negative 1. What does input negative 1 does to this function? To this one, you put negative 1 here, so minus 1 squared, negative 2 squared, 3 times 4, which is 12. Similarly, f of 3 equals 3 times 3 minus 1 squared, 3 2 squared, and 12. Both have the same output, but uh, but this is a function. So what this is saying is negative 1 is mapped to 12 and only one answer. The answer could be same, but negative 1 is mapped to 12 and 3 is mapped to 12 as well. The other thing what I can show you here is sometimes these kind of problems also appear. Now f of x, the question is 3x minus 1 whole squared. The question will be, what is f of x plus 2? Okay, so instead of x, what if your input is x plus 2? There is still an x in there. So instead of x, what I'll do is I'll just let's look at another color. So my input changes to x plus 2. So I'm going to write x plus 2 for x right here and then do the same thing minus 1 whole squared, which becomes 3. Combine these two, which is 1. So it becomes x plus 1 whole squared. It's a totally different function. F of x plus 2 becomes 3 of x plus 1 whole squared. Okay, so f of x plus 2 is not same as just writing 3x minus 1 whole squared plus 2. No, your input is changed. Input has become plus 2. Okay, like if you remember the left shift, so this is x plus 2. Okay, so the next example right here is determine whether the following are functions. I copied it from a website, I believe. Hopefully, they are all correct. The first one is if it's given like in the ordered pair form, it means 1 is mapped to 2, then 2 is mapped to 3, then 3 is mapped to 4, and 4 is mapped to 5. Yes, it is a function. For every domain, for every input, there is one output. And they have this reasoning because all the first elements are different. If your first element is repeating, for example, in this case, that 1 is mapped to 6 and also 1 is mapped to 9, so 1 is mapped to 6 and 9 in the third case, that's not a function. So another way to see what is the difference between a function and a relation. Okay, so that's it from me now, and let me know if you have any question. Take care.